Hello friends, welcome to my channel Physics with S.E.T.I. In the present video, we will see what is drag equation and how drag equation and S.E.T.I project are interwoven with each other. In the previous short in my YouTube channel, I explained what is S.E.T.I project. It means Search for Extraterrestrial Intelligence. In that project, physicists are looking for intelligent civilization within our galaxy using optical and radio telescopes. Earlier, I explained that since radio waves have longer wavelength in radio telescopes, there is high possibility to have detection of such kind of civilization. Since radio waves could penetrate between thicker gaseous cloud and dust cloud, and that is why many radio telescopes are used for that purpose, like Square Kilometer Array and many other telescopes. In the present video, we will see what is drag equation. Drag equation is the theoretical framework which could predict the existence of intelligent civilization. Another thing is, if this intelligent civilization is there, whether they will send any kind of electromagnetic wave to us or not. Third thing is, if they will send electromagnetic wave to us, whether we could receive and decrypt or not. So these are the possibility. Using this equation, we can understand these things. Let us see. So in 1960, astronomer Drake had made the first search for signals from extraterrestrial intelligence under Project OSMA. So this project was launched to have any kind of signature of intelligent civilization within our galaxy. So what is the purpose of this equation? To estimate how likely it was that other intelligent civilization existed in the galaxy and might perhaps be transmitting signals that we could detect by observing programs covered by setting. So by this way, drag equation, which is theoretical equation, is deeply related with SETI project. So in this equation, there are two parts. First part explains how often intelligent civilization arise in our galaxy. Second part explains the period of time over which such a civilization might attempt to communicate with us once it has arisen. We know that after development of many centuries, we could reach at this point. I'm talking about our civilization, that we can have wide range of electromagnetic spectrum, wide range of technological advancement, and by using these all things, we are looking for intelligent civilization in our galaxy. Similarly, if any kind of civilization is there in our galaxy, they have to follow the path of evolution. And that is why, first of all, existence of civilization might be there. And in the second choice, if any intelligent civilization is there after evolution and after development of science, they will communicate with us in electromagnetic spectrum that we are observing. This is the very important thing. If we receive signal which is beyond electromagnetic signal, which is beyond our technological advancement, we could not predict existence and presence of such kind of civilization. So it might be a case that they might have communicated with us, but we couldn't receive their signals. So in the drag equation, there are 8 factors or 8 parameters, and it is represented as capital N is equal to R star into F of Fp into Fe into F1 into Fi into Fc into L. Let us see how we can interpret each parameter in this equation. Here n represents number of civilizations in the Milky Way galaxy with which communication might be possible. Here red is talking about cases that there are many civilizations present in our galaxy, and among all these civilizations we have very few possibility to have communication with this civilization. So, and here Trek tells that number of civilization in the Milky Way galaxy with which communication might be possible. So there are many civilizations, but we are talking about civilization with which we can have communication by some means. Second parameter R star represents average rate of star formation in our galaxy. As I told, in universe, according to one estimation, there are 10 raised to 11 galaxies. And according to one estimation, in each galaxy, there are 10 raised to 11 stars. And that is why we have to study this parameter. That is average rate of star formation in our galaxy, since each star has its own solar system. Third parameter is FP, which represents fraction of those stars that have planets. We have to study stars which has planets similar to ours, similar to our Earth or other planet, which could accommodate life of carbon based. And that is why this parameter is used in this equation. Fourth parameter is NE, which tells that average number of planets that could potentially support life per star that has planet. As I told, we are carbon-based life, and that is why if any civilization might be there in our Milky Way galaxy, they must support carbon-based life, since hydrogen, helium, lithium, up to carbon elements are there in abundance in our universe. And carbon based life is the most probable life form in our universe. And that is why we have to consider this parameter, that is average number of planets that could potentially support life per star that has planets. We have to study many parameters which could support life in any planet, like temperature, pressure, atmosphere, etc. That we will see in many other videos of my YouTube channel. Fifth parameter is F1, which tells us that fraction of planets that could support life that actually develop life at some point. We know that we could reach up to Homo sapiens sapiens species by evolution of many years. So there is one possibility that if life is there in any kind of planet, it will take many years. So we are looking for life at any point, whether it is in past, present, or future. We can have signals of past and present, but we couldn't have signals of future. Sixth parameter is Fi, fraction of planets with life that go on to develop intelligent life. Only life is not enough. That life or civilization must be intelligent to communicate signals with us that we could receive and decrypt. This is the choice that choice is only we have. We have to consider it. Otherwise, we cannot have presence of such kind of intelligent civilization. Seventh parameter is FC, fraction of civilization that develop a technology that releases detectable signals of their existence into space. So as I told, right now we have technological advancement in which we can have communication based on all kind of electromagnetic waves, right from radio waves to X-rays. If such kind of civilization will communicate with us outside the electromagnetic spectrum, we couldn't have experimental signature of presence of such kind of civilization. So this is the possibility that we have to consider, that if intelligent civilization is there, they have to send electromagnetic waves within electromagnetic spectrum so that we could receive and decrypt their message. Last parameter is L, which tells us that length of time for which such civilization release detectable signals into space. Here we have to consider some kind of duration. Suppose they have sent us any kind of electromagnetic wave for a very short interval, but after some times when we receive it, we will receive in terms of past, as our universe is very far. Our Milky Way is approximately 1 lakh light year across. And that is why if they could send any kind of signal to us, and whenever we will receive, it means we will receive the signal of their past. And to receive such kind of signal, they have to send such kind of signal for a larger interval of time. Then we can have experimental signature of presence of intelligent civilization in our Milky Way galaxy. So this is the Drake equation which predict the existence of intelligent civilization in our Milky Way galaxy in some scenarios. If these scenarios are satisfied, we could have such kind of observation and we could predict the presence of such kind of civilization. So in the present video, we show that how Drake equation and S.E.T.I project are interwoven with each other, and how Drake equation is integral part of S.E.T.I project. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have a question regarding this lecture, you can ask in the comment section.